Hello learner, welcome to the learning of computer networks and security. Let's continue with the module 3 concepts. Let's see the protocol. The protocol is OSPF, Open Shortest Path First. So this particular protocol is again intra-AS routing protocol. So here the name itself indicates shortest path is chosen to route the packets inside the autonomous system. So that is within the autonomous system. If you have multiple routers, these multiple routers will redirect the packets through this protocol, that is through the shortest path calculation. So here the name indicates open, publicly available. So the meaning of open is this particular protocol is publicly available, and here in order to calculate the shortest path in OSPF, linked state or distress algorithm is used. Like in RIP, we are using distant vector algorithm to calculate the shortest path, but here in the OSPF, linked state algorithm or distress algorithm is used to calculate the shortest path. Remember that. And here how the linked state algorithm works: any router which has to redirect the packets, first it has to calculate the shortest path, right? So the router will calculate the shortest path from itself to its neighbors first. So that path, whatever it has calculated, whatever the node is calculated or whatever the router is calculating, and that shortest path should be circulated among all the nodes inside the autonomous system. So it is something like OSPF advertisement. We call it as OSPF advertisement. So what is OSPF ad, or what do you call that as, the information or the shortest path? So this ad is nothing but the shortest path, what it includes, and that information, that shortest path contains the distance from itself to its neighbors, and that ad is now circulated to all the nodes here in the within the autonomous system. So throughout it is circulated. So here OSPF ad is circulated, and here next you can see it is actually the routing protocol. You can call this as IS to IS routing. So it is something like intra-AS routing, or it is internal to the autonomous system. So this is what you have to remember. Some of the features, other extra features of OSPF we can see here, so which is not there in RIP. So you can see this as a difference between OSPF and RIP. So in OSPF we can see the security feature is added. So the meaning of security is the OSPF advertisements or the OSPF messages whichever is circulated inside the autonomous system is highly confidential, which cannot be compromised by the third party or which cannot be leaked to the other organization. So this is specific to a particular organization, and you call it as authenticated info messages or authenticated advertisement circulated. Next you can see here in OSPF we can have same cost path, multiple same cost paths. So what is the meaning of that? Suppose if I have a autonomous system in which I have routers or something like this. So suppose I have routers connected across with each other, that is inside the organization within the autonomous system. So in this case, suppose if I have a router 1, it can reach this router 2 via multiple path, right? So here router 1 to router 2, their cost may be 1, here this again cost may be 1, and this again may be cost 1. So this may be the cost 2, and this may be the cost again 2. So here you can see the cost or the distance from router 1 to router 2 you can have multiple path, right? So multiple path here is something like, let me change this. Okay, this cost I'll take it as 2. So the cost to reach from 1 to 2 is 2 here, that is direct path. But there is one more path to reach from 1 to 2. What is it? That is the cost to reach from 1 to this router. Let me call this router as third router. 1 to 3 is 1. Again, the cost to reach from third router to second router is 1. The total distance from router 1 to router 2 is how much? Again 2. So do we have the same cost path? I have two same cost path here. That is one is distance 2 and one more is 1 plus 1. The distance is again 2. So we call this as multiple path, which is allowed here in OSPF. But that multiple path we may have in RIP also, but that is not considered. But in OSPF, such multiple same cost path is considered. That is the difference. And why are we considering this multiple same cost path? So that is actually for providing different types of service. So types of service, when you say, some of the if I suppose take this particular path, the cost is 2. Sometimes this path may be heavily loaded, multiple packets might be sent here, so the link will be overburdened in that case. So you can just take here the other path there. So what is that other path they're saying? Other path is nothing but this particular path with the same distance I can choose, because this path is lightly loaded. So that is why for different types of service, depending upon the link burden or link capacity, you can choose multiple same cost path. So here also we have one more feature explained, that is hierarchical OSPF. In hierarchical OSPF, we can just see here, I have two levels. So level 1 and this is level 2. So what is this level 2? You can see this is the bottom level, and you can call this as a local area, local area. So what is the meaning of local area? This is nothing but simply one autonomous system. You can have a group of routers which is formed as a local area. So one area, you call it as local area, which contains a group of routers, and I can call this as one autonomous system. Again, you can see this is also the second local area. Again, this is the third local area. I have total 3 local areas, 3 groups of routers, 3 autonomous systems. Now, all these 3 autonomous systems, local areas, are connected or they are connected across each other through one common area, and that common area you can call it as backbone area. So this blue area, you can call it as a backbone area. This backbone area, you can call this also as a provider, network provider, service provider, something like that. Instead of calling it as service provider, you call it as backbone provider area. So this backbone provider area, actually its responsibility is to choose the shortest path, to redirect the packets outside to the outside world. You can call this as AS1, AS2, AS3, all 3 belonging to the same organization. All 3 AS are connected across each other through a common backbone area, and that backbone area is the one whose responsibility is to calculate shortest path to circulate the packet sent by local area 1, or maybe the packet sent by local area 2 and the packet sent by local area 3. Or if at all any one router in area 1 wants to send the packet to a router in area 2, so that packet also can be redirected via the backbone. But backbone's policy is to calculate the shortest path here to redirect the packets, and that packets be also redirected to outside the organization. So you can see there is one router, special router inside the backbone area, that you call it as boundary router, whose job is to redirect the packets outside the organization, again to welcome, or you can say to receive the incoming packets from outside the organization to inside the organization. So here there is this boundary router here, whose job is to connect to the outside world, and inside the backbone area, I have also area border routers. So what is this area border routers? These area border routers are part of this local area itself. Every local area should have one border router, and you call that as area border router. So this is the first area border router, second area border router, third area border router. So all three border routers are the one which is actually connected to the backbone, which is a part of backbone, and through this area border routers actually the packets are sent to the backbone area. So in the backbone area, again I have here the boundary router through which the packets are redirected to the outside world. So this you call it as hierarchical OSPF. As I already said, we have two levels. One is the local area, the other one is the backbone area. So you can see here all link state advertisement, or you can say it is a distress which is followed to calculate the shortest path, and all advertisement OSPF ads are circulated. Okay. Area border routers are specialized routers there whose job is to summarize the distance, or you can say to calculate the shortest path and to circulate this advertisement to other area border routers. So backbone routers are the one which is inside the backbone area. So again its policy is to run OSPF routing protocol wherein shortest path is calculated, but all these routers are calculating it is functioning inside the backbone. Finally the boundary router is the one which will connect to the other organization. You can say from one system, one organization to the other organization. We have now the next protocol, that is BGP. You can call this BGP as Border Gateway Protocol. This Border Gateway Protocol is actually inter-AS routing protocol. Inter-AS routing protocol is across to organization, across to autonomous systems. If at all you have to communicate the packets, send the packets or receive the packets, you have to make use of this protocol, BGP, Border Gateway Protocol. So we have here, you can call this as a glue that holds two autonomous systems, or you can say that holds internet together. So in BGP again we have two sessions or two types. One is eBGP, the other one is iBGP. So what is this eBGP? External BGP. iBGP is internal BGP. So here external name itself says this BGP is Border Gateway Protocol, which should be implemented at the border routers only. So I hope it is clear, only at the border routers this protocol should be implemented, and here the border routers job is to circulate the ads to the other organization, to the other autonomous system, right? So for that eBGP is used, or eBGP session is initiated. So wherein the information is circulated. What information is circulated? All reachability information. What is the meaning? So this border router will have the information about all the routers that is reachable inside the organization. So that reachability information is actually shared to the other organization's border router. So our border router will share the information about our organization with the other border router which is belonging to the other organization. So here when I say organization, I refer to this autonomous system. Again, you can see the next type of BGP is iBGP, that is internal BGP. So again, this border router should calculate first all the reachability information inside the autonomous system. So this reachability information inside the autonomous system is calculated through iBGP. Again, border router only is initiating that. So you can call that as good routes are calculated. Good routes are nothing but the best shortest path is calculated inside the organization. So that information is actually circulated later. We can just see few basics of BGP. So BGP session is actually created. So you can just see this diagram here. I have a border router 3A which is belonging to AS3. I have again a border router 1C belonging to AS1. I have a border router 2A belonging to AS2. So across the border routers, this communication is happening through BGP. So BGP should be implemented at 3A, 1C and 2A. So first eBGP, you can say eBGP is initiated. So for that, first BGP session should be created. So what is BGP session? BGP session is the one across which the messages, BGP messages are communicated. So here eBGP, through eBGP, BGP session is created, and now the advertisements or maybe the reachability information is circulated in the form of BGP messages. So 3A will share the information with 1C, again 1B also will share the information with 2A. So advertisement path is actually circulated through BGP session. You can see AS3 is advertising to AS1. So what is the information contained inside this advertisement? It is nothing but, you can call it as the one is two informations are shared. One is prefix information that it is shared. Prefix. So one more is you can say the path information is shared. So here first I will tell you about the path. What is actually the path that is circulated? So I'm sending the packets from AS3 to AS1, right? So the path is nothing but simple. It is AS3 to AS1. Just the autonomous system path is specified, and that path is the information which is maintained in the ad. That is one thing. And one more is the prefix. What is the meaning of prefix? It's nothing but the subnet address. You can see all these routers will have some subnets connected to this inside the organization, inside the autonomous system. So all these subnets will have one unique address, right? So all these subnets, subnet addresses will be unique, but the first part of the subnet address, what you call that first part of the subnet address, you call that as prefix. So all those subnets here inside the AS3 will have common prefix, and that common prefix is actually shared as a reachability information with the other border router which is part of AS1. So our border router 3A will share this prefix to the other border router, so that here this border router will come to know that which are the reachable subnets here inside AS3. So that border router 1C later will redirect that information to all the other routers here inside AS1. That is why when a router wants to send a packet to any subnet here inside AS3, with the help of that reachability information, with the help of that prefix, easily it will come to know to which the subnet is belonging to which AS. Right, so subnet is belonging to which AS3, that information is actually that will be known to every router here inside the other organization. So once it is known to all the routers, that router can easily redirect the packets. Right, so this is the prefix and the path information that is shared through BGP messages. You can call this as the prefix as also as aggregate. So what is the meaning of aggregate? All these subnets will have unique addresses which will be aggregated into one common prefix, and that common prefix is actually shared as advertisements. You can also see now how the BGP session is created between 3A and 1C. So 3A and 1C, prefix reachability information is shared, or that aggregated prefix is sent. So here you can see 1C can make use of this here eBGP session is created. This thick line indicates eBGP session, whereas after once it gets that prefix and path information, our 1C should share that information among all the routers inside AS1, right? So it should share the information to 1A, 1D and 1B. So this is shared through iBGP session, and you can see that a dashed line here, that is iBGP session is used. Through that all the BGP advertisements, whatever it is received, that will be shared with all the routers here within AS1. So both eBGP and iBGP session is initialized, and here the prefix information is shared, and that prefix, whatever is shared, every router will record that inside its forwarding table. That information, reachability information or prefix information, is maintained inside the forwarding table at every router here. We can now see the next important point, that is path attributes and BGP routes. So what is path attribute? So what are the attributes that the BGP advertisement contains? So first one is the route, the prefix that is shared as a BGP attribute, and you can call that as prefix plus attributes, which forms actually the route. So what is that? We'll just see here. Advertised prefix includes BGP attributes. So here when I say the prefix is shared, it actually includes BGP attributes as well. So what is the meaning of BGP attributes? So I have two attributes. One is AS path, the other one is next hop. This will actually help us in reaching from the source router to the destination router. Now here we have the prefix path in AS, that is, let's take an example of some AS, say that is AS2. So here I have the one of the subnets address is 138.16.64 and 24. So what is this 24? It indicates the number of bits here. So this first three parts in the address, you call it as the prefix, right? This is the total number of bits there used. So out of 32 bits, it is actually the first 24 bits is indicated here. And next, again, the next subnet address is this, the third subnet address is this, and the fourth subnet address is this. So everywhere you can see here the prefix part. So what is that prefix part? You can call this as you can aggregate all these four subnet address into one. So what is that aggregated single prefix? 138.16.64/22. So what is the meaning of 22 here? The first 22 bits is shared here, which is common here for all the subnets inside a particular autonomous system. First 22 bits are common. So that particular aggregated prefix now is shared through the border router. Here we are speaking about which AS? AS2. So that is shared here with the border router 2A, and that border router now will circulate through eBGP session. That information is circulated to the other border router 1B. So with that, our 1B will learn the prefix or all reachable subnets via AS2. So our border router 1B will learn that will be recorded in its forwarding table, and through iBGP session, that reachability information is circulated to all the internal nodes inside this AS1. So this is one information, that is prefix information. The next information that is shared is attributes. I said AS path. So what is the AS path here? In order to redirect the packets, the path is AS2 to AS1, or else if I have to redirect the packets from AS3 to AS1, the path would be AS3 to AS1. So this is a simple path. And one more attribute included is next hop. So what is next hop here? The first router that you're using to redirect the packets. So what is the meaning of first router? For example, I have a subnet here. Let me take a subnet here. That subnet is say connected to 2B or something. Okay, this is a subnet that is connected to 2B. So if I have a next hop, so if I have to redirect a packet, suppose here a router 1D wants to send the packet to this subnet X. So 1D is belonging to AS1, but X is belonging to AS2. So whether 1D will know that X subnet is belonging to AS2, definitely it will know, because it will 1D, if at all has to send the packet to X, it should know the address of that X, subnet X. So whether that information about the address is maintained in 1D, definitely yes. So the subnet address of X will be shared via border router 2A to 1B, and via 1B it has reached 1D, and 1D will know that it has to, in order to reach the subnet X, first it has to contact the border router 1B, and through 1B only he can contact AS2, and through that he can directly reach this subnet X. So router 1D, what it will do, it will add a prefix, and the prefix is the address, the first part of the address of subnet X, and also the AS path is included. Path is AS1 to AS2, and the next hop router also is included as an attribute. The next hop router for this is 1B. So this is the first router along the path. This is the first router. Whenever you have to send a packet, this would be the first router which will redirect the packet to the next subsequent routers. So you call this as the next hop router. Two attributes are included here. Okay, so this is how. And finally our gateway router is nothing but the border router, which will receive the advertisements, and finally it will just redirect the package to the other autonomous system. BGP route selection we have now. Okay, so here we can just see the four policies used. Okay, the first one is the route is selected based on local preference value attribute, shortest AS path, closest next hop router, which is also called you have a concept called hot potato routing, and then the additional criteria. So what is the meaning of these four policies here? Okay, so we'll just see that with the help of a scenario here. So we have this scenario. You can see there are 6 subnets listed. So not subnets exactly, autonomous system. So what are the autonomous systems we have? W, X, Y, and then A, B, and then C. So total there are 6 autonomous systems. So out of these we call these W, X, and Y are stub networks, and these are the 3 backbone network, you can say call it as backbone network, yeah, backbone systems also. One is A, then is B, and then C. So backbone providers, you can call them as backbone providers. So what is the meaning of this? So suppose here autonomous system X wants to send a packet to an autonomous system W. So here any one subnet within this autonomous system X wants to send a packet to W. So what are the routes that it can take? First, it can take a route through B, X to B, and then B to A, and then finally A to W. So what exactly is this route means? So X has to redirect through its border router to the backbone router here inside this autonomous system or backbone area B. So it is actually, I called it as a provider, right? So what is the meaning of provider? They are the provider of this bandwidth, right? So the bandwidth that you have utilized to redirect the packet is provided by this provider, backbone provider B, and then B will show the path via A. Now A is going to provide you the backbone, or A is going to provide you the bandwidth to reach the subsystem, or you can say autonomous system W. So B and A has invested here in order to redirect the packets. Now there is one more route here what X can take, that is via C. So if at all X has to reach W, it can also redirect through the backbone area C, and then it can reach to A, and then finally it can reach to W. Now here this path, X can take this path or it can take via B, right? But here the problem is B knows the path to reach W. If B knows the path to reach W, whether that information is shared with the router, the backbone area C here. So B will have the information about reachability information about this W, whether B will advertise that information to C, backbone provider C. If B advertises this information to backbone provider C, then what would happen? C as a backbone provider, he will simply redirect all the packets what Y is sending to it. It will redirect the packets to B, and via B it will redirect the packets to W. In that case, what would happen here? Y will take a path to C, and then C to B, then B to A, then finally to W. So what would happen? Instead of C taking the burden of redirecting the packets to W, C will redirect that to B. So it is like unnecessary burden on the provider B, right? So if at all anymore if C comes to know that there is a path to reach W via B, anymore if any packets that X sends to C, instead of C sending it to W via A, what C will do? It will just tell the X here that there is a path to reach W via B. correct? So C anymore will catch hold of that information, reachability information, and it will inform both X and Y here, which is connected to C. It will just say that instead of redirecting the packets anymore via C, you can redirect the packets via the other provider B, so that the burden on C is reduced and C doesn't have to invest on it. So all the burden should be taken in that case by a provider B, right? So this type of problems might occur in the network. So here we have for that local preference value. So what is the meaning of preference here? The preference is provided by this on this backbone provider. So here local area, you can call this as local area X, local area Y. So local area can be contacting backbone provider B, or it can also be contacting backbone provider C. So local preference, so it has to take the policy decision. So what is policy decision? Based on the burden and based on the availability, the packets, incoming packets should be taken, and that is how it should be reached to the destination. There should be a policy which has to be followed. It's not like burdening a single provider or something. Next, shortest AS path, always it should be chosen. So any algorithm, Distrust or Bellman-Ford, any one algorithm can be chosen to calculate the shortest AS path, and that is how it will reach the destination. And then the closest next hop also should be chosen. So what is closest next hop? X can reach W via C as well as via B, but the closest next hop should be taken. So maybe B is closer compared to C, or C is closer compared to B. So that calculation should be done, and based on that, the closest next hop should be chosen to choose the best path there, right? So this is how the route selection is done in BGP. Finally, the BGP messages are exchanged via eBGP session and via iBGP session. And what is the BGP message contains? BGP message always contains the information about open. So this BGP messages can be circulated through you can say TCP connection. TCP is nothing but transport layer protocol. So through this TCP connection, you can call this as a reliable connection. Through reliable connection, this can be communicated so that the data will remain authentic and the data will be secured there. Then the path information should be every now and then, if it gets updated, if any link fails or if any path changes, in that case the new path should be always advertised. So this BGP is used even for advertising the new path. And then this BGP session, in BGP session always the connection keeps open. It keeps the connection open, or the connection will be alive even if there is it's something like if there is no updates that is to be sent, if no advertisements has to be sent, in that case also the connection will be kept open. And then finally the notification, like any errors occur, like if any link fails or if any router is removed or something like that, if such errors occurs in the network, so that information also will be circulated, and therein it also redirects, notification will be sent to close the connection. So if any such error occurs, the notification will be sent to close the connection through BGP session. So this is the information contained inside the BGP message. This is all about the BGP basics what we have.